Modular arithmetic is a useful tool in number theory, so therefore we will study a little bit more here. You say that A and B, you say those are congruent modulo n. Okay, so you say this sentence, A and B are congruent modulo n, and that means n divides A minus B. So you could say that this is a complicated way of saying it, or expressing that n divides A minus B. So, okay, so A and B are congruent modulo n if their difference between numbers is divisible by n. There's also a shorthand for this. You write this as A congruent, this means congruent, to B modulo n. So instead of saying this sentence here, you can write A congruent to B modulo n. And that just means that n divides A minus B. That's the definition of it. So it's the same thing because of per definition. So let's take some concrete examples. For example, 13 is congruent to 4 modulo 3. And why is that? Well, that's because 3 divides 13 minus 4. That is, 3 divides 9. Since 3 divides 9, 13 is congruent to 4 modulo 3. Or you take another example. 18 is congruent to 3 modulo 5. Why so? Because 18 minus 3 is equal to 15, and 5 divides 15. On the other hand, you have that 19, for example, is not congruent to 3, and that you write this, you cross over. So 19 is not congruent to 3 modulo 5, and that's because 19 minus 3, which is 16, and 5 does not divide 16. Okay, so this is just what it means to say that two numbers are congruent modulo n. These strange words here just means they're talking about the divisibility of their difference. We don't have to limit ourselves to positive numbers. We could also say, for example, 10 is congruent to minus 4 modulo 7. And why so? Because 10 minus minus 4, which is 14, is divisible by 7. So this is 10 is congruent to minus 4 modulo 7 because 7 divides 14.